Good afternoon, everyone. Thank you very much for coming to this presentation. I will be presenting a little bit of my work on using learning log data for group work. I am Ivica BOTICKI. I work as an associate professor at the University of Zagreb in Croatia, a small European country, but if you watch football last year, then you probably know that Croatia is amazing in so many ways. In any case, I would like to thank my colleague, Professor Hiroaki Ogata, for having me here at his lab in Kyoto for a short period of time. I will be talking about group work and collaborative learning. So could you please tell me, does anyone here use collaborative learning with their students? Who did try? Okay, so you probably know it's actually very difficult, it's very hard, but it's also very rewarding, and collaborative learning will be part of, and I mean it is at this point, but also will be part of future skills that our students need. So it's not enough to master content, only master content, and to be a good scientist. It's important that our students know how to communicate with people and also to engage in multidisciplinary research. So I will just briefly go through some things in collaborative learning, although I know you probably know these things well, but just to briefly cover all the things, it's very important that when we put students in groups, they have a common goal. As a teacher, I need to define it. And also, we need to create some relationships between students. We call it positive interdependence among peers. So there needs to be some, like, this balance, so they are forced to work together. They need to agree on things, and they need to be individually accountable for their work. So it's not like really good that we grade the whole group in the end, only the whole group. We have to grade them individually as well. So these are some of the very important things that come from collaborative learning research. But I will be talking about a very, very specific niche today, which is synchronous and co-located collaborative learning. With technology, of course, we call it CSL, computer-supported collaborative learning. So just an example, so these are the students which are co-located, they work together on a problem, they communicate face-to-face, but they also use some kind of technology. We are very interested in that scenario. So how can our technology be used to support such collaborative processes? And I'm going to talk about learning logs today, as well as my colleagues before me, in context of this. Okay, a very important thing, if we want to do good collaboration, we need to have good interaction. We need to structure interaction. Group work will not happen on its own. If you just put students in group and say, work together, trust me, it might happen if you have amazing students, but usually it won't. So we need to structure, we need to design for interaction. We call it scaffolding. So we provide them some steps, or we provide them clear guidance on how to do collaboration. So these are the research questions. I will not go deep here. It's very important in our research work to use a learning analytics system. So this is log data that we have been witnessing in our last presentations to support teachers in managing group work, and also to create students' models that come from the student data to understand how our students are, so we can support them in group work, and to analyze what is the effects of all this use of the log data and group work, and to predict our students' success. So these are some of the challenges we are working on in Ogata Lab, and it's actually very exciting. We're examining this from the two levels, teacher perspective and also technological perspective. We know that teachers need to choose the students, identify the task for collaboration, and they need to decide on many, many parameters, and then they can form groups. Technology, on the other hand, is successful in forming groups and for supporting group work. We can use technology for some synchronization, for sequencing, state preservation, and so on. We are using also book roll. You have been witnessing so many presentations today about book roll, and there will be many more very exciting presentations. As you can see, an amazing system that is used at so many locations. We are actually using the Learning Record Store to store all this amazing and rich log data. But also we have analysis database, which has a student model. So this is our data, our variables, which tell us how our students are. My colleague, also from Ogata Lab, Gökhan, will talk much more about one additional exciting thing, and this is the dashboard. So we can visualize, and our teachers can see how the system works. Okay, so in any case, for collaborative learning, for group work, we need this a lot. We need this student model a lot, because we want to use all these variables: scores, engagement, reading styles, how our students read, are they fast, are they slow, are they quick, do they jump, do they return, do they reread, and so on. Prior group work, if they were good at group work before, whether this can like improve their future group work, how is the content related to their success, and how can we use this for group work? Some students know some content, some students know it less, the other students are good at something else. Brandon will talk about it a little bit more later. In any case, back to the, to the concrete stuff now. We created a group formation tool. We can choose grouping algorithms, homogeneous, heterogeneous, random. We can choose user model variables. These are stored in the analysis database. And these actually variables draw from a huge amount of data, and there are some algorithms that process this data, so we can have these very nice variables. Teachers define group size and some other parameters and choose the students who will participate in group work. After that, our system has a group work console. So these are the groups that were created automatically by the system depending on different variables and different data. And these are the student members. I anonymize it here so we don't see the real names, but the names are shown here. And these are the different categories that the teacher can use to grade the students. Okay, so a teacher can grade collaboration quality, collaboration speed of this particular group, and performance as well. Okay, so this is actually the work on group formation tool, and after all this, as part of our dashboard, we have different kind of analysis. So the teacher can see, oh, which algorithm was the most successful? Was it heterogeneous? No, actually, the use of homogeneous algorithm in this case was the most successful. The students gain best result. But the teacher can also see what are the group scores. So can examine how the groups were graded throughout the time. So this is the first part of our work, supporting teachers, giving teachers the tools so they can actually scaffold or structure the group work, and they can have good interaction that will later result in good collaboration. Another very exciting thing, which I call group work here, we are working on, is collaboration with the NEC company. This is a magic device, a really magic device. Magic happens here. We put this device in between the students, and the students work together as part of a group. And this device actually captures their conversation. Whatever they say, this device will capture, and it will process it. It will convert their speech into text. So we can do natural language processing. We can do analysis of what the students were working on. Imagine how exciting this is. Why is it exciting? Because if we can have real-time data from this device, we can recognize what students are talking about every second. And our analytics platform can actually give them tips, hints, and help them in the group work process. This is, I would like to relate to the interactions I was talking about, and scaffolding and structuring interaction to achieve better collaboration. This is a unique opportunity for us to actually use the power of this magical device. We will do, this is just preliminary, as I said, future work. We will do keyword identification, try to identify keyword topics. This is quite early. We are struggling with tokenizers, Japanese tokenizers. Now, currently, it's hard. In any case, this device also provides us with numerous opportunities for an amazing analysis. For example, this one, it can identify sentiment. How do students feel at certain point, whether they feel joy, sorrow, anger, and so on. We'd like to use that. We will use that in the future as part of our future work and future plans to triangulate this data with their collaboration and interaction in real time. So that will help us to contextualize what's happening in group work more. Of course, we will have other quantitative stuff like number of words, number of utterances, and how much they speak. But we find this really exciting because we feel knowing emotion can also help us a lot to help our students in group work. So this is all for today from my side. My colleagues will actually continue explaining more and more about our work, in our exciting work actually in Ogata Lab, and they will explain more of the things, and hopefully we can continue our discussion afterwards and also have some exciting collaborations. Thank you very much for your attention.